Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're looking at multiplying 8's. And we're going to think about multiplying 8's through scaling. And what is scaling? Well, scaling has to do with making things grow bigger or making them smaller. Let's start here. First off, I need something to measure. So I'm going to draw a line here. And this is the thing that I'm going to grow and see how big we can make it. Let's call this 1 unit of measure. So we'll just say this is 1. Now what happens if I want to grow it bigger? Well, what if I wanted it to be twice as big as this? Well, let's do that. We know that if we want to make it twice as big, we have to grow it one more time. So this is the same size, but to make it twice as big, we'll need to double it, right? So we need to make it grow all the way to here. And we can say that this line here, 2 measures long, is twice as big. That means that this is just 1 times itself. So this is 1 measure. This is twice as big. What happens if we want to grow it more? Well, let's do that. Let's make a base here, and we'll grow this line too. First we'll grow it 1 measure, 2 measures, 3 measures. So we can see that this line is 3 times as tall as that line. So we've grown it to be 3 times as tall. Alright, so this is 3 times as tall. 3 times as tall. Let's add another line. Let's grow this one 4 times as tall. Alright, so here we go. And this line has 4 measures in it. So it's 4 times bigger than this one. Alright, so 4 times as big. Another one. We should make this one 5 times as big. 1 measure, 2 measures, 3 measures, 4 measures, 5 measures tall, stretched up tall. And this one is 5 times the measure of the first one. 1, 2, 3, 4, 5, compared to just 1. Another one. Let's make this one 6 measures tall. 1 measure, 2 measures, 3 measures, 4 measures, 5 measures, 6 measures tall. So this one is 6 times as much. 1, 2, 3, 4, 5, 6 times this first measure. And the next one will have to be 7 times the measure, right? Let's build it. 1 measure, 2 measures, 3 measures, 4 measures, 5 measures, 6 measures, 7 measures tall. And it's 7 times the height of the first measure. Okay. The next one, this one will have to be 8 measures, right? 1, 2, 3, 4, 5, 6, 7, 8 measures tall. So being 8 measures tall, this line is 8 times as tall as the first measure. Let's do one more. This will be the tallest of all. So let's start a base and climb up. 1, 2, 3, 4, 5, 6, 7, 8, 9 measures tall. That tells us that this last one is 9 times as tall as the first measure. So this is what scaling looks like. Something can be made one size and then grow and grow and grow and grow. But we also have to remember that scaling means things can shrink too. So it could go from this long measure, smaller, 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 to the least measure. All right. So that's what we know about scaling. But how does this help us with multiplying 8's? Let's try it out. I'm going to put a stack of boxes here, 8 boxes. Okay, so I put 8 boxes here, and I know that I have one stack of 8 boxes. How many do I have altogether? I just have 8 boxes. Okay, that's good. What if I want to double this stack of 8? I need to make it twice as tall. What will happen? And how many boxes will there be? Well, I'll have to make it twice as tall, right? So let's go ahead and do that. Here's one stack of 8 boxes. Here's another stack of 8 boxes. So we can see now that it's twice as tall as the first stack of 8 boxes. So 2 stacks of 8 boxes is this tall. But how many boxes are there if there are 2 stacks of 8 boxes? 2 stacks of 8 boxes means 8 and 8 more. So that's 16 altogether, right? What if we want to make it 3 times as tall as the first measure? All right, so 1, 2, 3 times the first measure. 3 stacks of 8 boxes. All right, how many boxes altogether? 8 and 8, 16. 16 and 8 more give us 24. This is 3 times as many as our first measure. 3 times as many. What about 4 times? Well, let's make some boxes. 1 stack, 2 stacks, 3 stacks, 4 stacks of 8 boxes. All right, so how many boxes altogether? 8, 16, 24, and 8 more give us 32. And this is 4 times as many boxes as our first measure. So this is 4 times as much as this one. What about 5 times the measure? Okay. 1, 2, 3, 4, 5 stacks of 8 boxes. 5 stacks of 8. How many boxes in all? 8, 16, 24, 32, and 8 more give us 40 boxes. So 40 boxes tall is 5 times as much as just 8 boxes tall. All right, 6 times. 1, 2, 3, 4, 5, 6 stacks of 8 boxes. 6 stacks of 8, how many altogether? Let's count them together. 8, 16, 24, 32, 40. Okay, and then 8 more. 40 and 8 give us 48. 48 boxes altogether. All right, let's go on to 7. Let's stack those boxes. 1 stack, 2 stacks, 3 stacks, 4 stacks, 5 stacks, 6 stacks, 7 stacks tall. 7 stacks of 8 boxes. How many altogether? Let's see. 8, 16, 24, 32, 40, 48, and 8 more give us 56. So 7 stacks of 8 boxes give us 56, which is 7 times as many boxes as our first measure, just 8. 8 stacks of 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8 stacks of 8 boxes. How many boxes altogether? 8, 16, 24, 32, 40, 48, 56, and 8 more? That gives us 64. So 8 stacks of 8 boxes gives us 64 boxes altogether, which is 8 times as many as our first stack. Let's do one more giant stack. 9 this time. 1, 2, 3, 4, 5, 6, 7, 8, 9 stacks of 8 boxes. What a tall, tall stack of boxes. Hope it doesn't fall over. How many boxes are there altogether? Let's count them. 8, 16, 24, 32, 40, 48, 56, 64, 64 and 8 more boxes. That gives us 72 altogether. So 9 stacks of 8 boxes. 9 stacks of 8 boxes gives us 72 altogether, which is 9 times as many as our first stack of just 8. So we can see how it's been growing, 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 growing across the way here. Let's think about this for a moment. Let's look at it a little differently. Let's start with 1, and let's think about this growing from 1 through 2, twice as many, to 3 times as tall, to 4 times as tall, 5 times as tall, 6 times as tall, 7 times as tall, 8 times as tall, 9 times as tall. This last one is 9 times as tall as the first one. So we can think about scaling as things growing and growing and growing. Can you imagine what will be the next ones? Now we can also think about scaling a different way too. We can think about scaling as doubling. So for instance, here's 3 stacks of 8 boxes, right? Well, if I double 3 stacks of 8 boxes, if I double this one, I find myself at 6 times 8 boxes, because you can see that the stack of 6 times 8 boxes is twice as big as 3 times 8 boxes. So that's one way of thinking of scaling. Now this is still thinking about it as growing, but what if we think about it the other way around? Scaling can also be shrinking. So what if I say I have a stack, I have 6 stacks of 8 boxes, but I only want it to be half as tall. So 6 stacks of 8 boxes, and you see how tall it is right now. What if I only want half as many? What does that look like? Well, half of 6 is 3. So half of 6, if you take 6 stacks of 8 boxes and you only want to have half as many, we can think of that as 3 stacks of 8 boxes. Do you see how this stack of 8 boxes is half as big as the 6 stacks of 8 boxes? So that's another way to think about scaling, as things getting smaller. So scaling is an interesting way to think about multiplication, and I hope this helped you think about it well.